Hello everyone, it's Miss Mather here. Welcome to week 3. I'll be taking you through the maths this week. We're going to be moving away from money now, and we're going to be starting a new topic this week, which is statistics. So this is going to be using data and looking at it and putting it into different charts and graphs. Today is Monday the 15th of June, and our LO today is I can represent data in a variety of ways. So we're going to be representing data. So this learning verb means that we're going to be showing our data, and we'll be doing this in a few different ways, including some charts and some graphs. So let's start by looking at some key vocabulary. So we've got continuous data, data, line graph, bar chart, pictogram, discrete data, and table. Do you recognise any of these words? If so, have a think. What do they mean? What do these things look like? And you can pause the video if you'd like to have a think about this. So this week we're going to be looking at two different types of data, discrete data and continuous data. So discrete data is data that has certain values. Each is distinct and separate, and it is counted. Often you're counting the amount of people who have an opinion or who share a certain characteristic. For example, favourite food. You might ask a group of people what their favourite food is and give them 4 or 5 options, such as pizza, salad, roast dinner, and burger. And they'll tell you what their favourite is, and you need to count the amount of people who like each food. So you might have 6 people who like pizza, 10 people who like salad, and 5 people who like burger, and 4 people who like a roast dinner. Okay, that's a distinct value, and you can count how many people like each food. So that's discrete data. Then we've got continuous data. Continuous data can have any value, and it is measured. For example, height, time, or distance. You can measure all of those. You have different units of measurement, such as you can measure height in centimeters, you can measure time in seconds, minutes, or hours, you can measure distance in meters or kilometers, and sometimes your data might not be a whole number, it might include a decimal. For example, it might be 1.5 kilometers. Okay, so it's data that can be measured. So, what are the different ways we can represent discrete data? So that was that first kind of data. So what sort of charts and graphs are we going to be looking at here? Well, we're starting off by looking at a tally chart. You might have come across this a few times before in school. Okay, so a tally chart where you've got those lines that represent one person, okay, one vote. Then we've got bar charts, which use coloured blocks or bars to represent the data. A pictogram uses pictures to represent the data. And you've also got a table, and a table we use quite often when we're recording data in science. So let's start by looking at a pictogram. Sometimes it's called a pictograph. And this is a simple way of representing data with a picture. So this pictogram is representing the pets that people have in class A. Okay, notice that we've got a title for our graph to tell us what it's about. We've also got a y-axis here telling us the number of pets that they've got in their house, and the x-axis is telling us the type of pet they have. So our data shows us that 2 people have a dog, 1 person has a cat, no people have fish, and 3 people have a rabbit. And you can see that because each one has been represented with a picture. So it's quite a nice way of looking at our data. Then we've also got a tally chart. We can collect and record data this way. Often you collect data in this way because it's quite quick and easy to do. So here our chart is showing eye colour. Okay, so here is our tally on that first row. So you can see each line represents one person who's got blue eyes in this case. So here we can count 1, 2, 3, 4, and then 5 strikes it through, 6, 7, 8. So 8 people have blue eyes. Remember, your 5 looks like this. Once you get to 5, you put a line through it, a bit like a gate. Black, we've got 1, 2, 3 people. Brown, I'm going to use my 5 times tables. I'm going to count in 5s. 1, 5, 10, 15. Okay, so 15 people have brown. 2 people have grey eyes. 4 people have hazel eyes. And oh, look, nobody has any green eyes in their class. Okay, so tallies are very useful ways of recording that data. This data can also be shown in a table, which is slightly different because the table is also quite simple to read, and you're showing the frequency, which basically means the total number once you've counted up your tally. Okay, so it makes the data even easier to read. So here our table shows in this column the choice of eye colour. This column is our tallies, and then this column is our frequency. So again, you can see now we were right when counting our tallies. No people have green eyes. So the question here is, what is the most popular eye colour for this class? What do you think? Well, the most popular is going to be the biggest number, and we can see here 15 is the biggest number. So a lot of people had brown eyes in that class. Another way of showing this could be in a bar chart. This kind of chart uses these columns or blocks to show the data values. And it's also quite a useful type of chart for showing bigger numbers and also for making very quick comparisons between different categories. So let's look at what it looks like. We've got our title at the top, eye colours in year 4. We've got our y-axis here with our title, our label for our y-axis, and our y-axis represents the values that are changing, okay, the different amounts of people. And this one is going up in jumps of 2. Your axis must go up in regular jumps. Our x-axis represents the category choices, and this doesn't change. So we know that these are the fixed categories that we asked them about, but these numbers can differ depending on how many people had each eye colour, okay? So again, you can see here, blue eyes, I can look across and see 8 people had blue eyes, because that's where my bar stops. Black eyes, I'm going to look across again, it's halfway between the 2 and the 4. So what's halfway between 2 and 4? It's 3. Brown, again, is halfway between 14 and 16. So 15 people had brown eyes, 2 people had grey eyes, and 4 people had hazel eyes, and nobody had green eyes. So what questions could this chart help us to answer? Have a think now, and you can pause the video. What questions could this chart help us to answer? Well, we might ask some simple questions such as, how many people had grey eyes? So the answer would be 2. You could also ask a comparison question. You could ask something like, how many more people had brown eyes than hazel eyes? So you'd be finding the difference. So in this case, 4 people have hazel eyes, 15 people have brown eyes. So the difference is 11. So 11 more people had brown eyes than hazel eyes. Okay, so those are some examples of types of questions that this chart can help us to answer. So how do we draw this type of chart? Well, you start with drawing your y-axis and your x-axis. It's good to use a ruler so you have nice straight lines, and squared paper also helps. You also need to label your y-axis and your x-axis and choose an appropriate title. Once you've done that, you need to use an appropriate scale, always starting at 0. In this case, we're going up in jumps of 2. Okay. but it depends on what your data is. This chart, it looks like it's about 4B school houses. So we've got Severn, Trim, Avon and Frome. And then we're going to find out how many of children in 4B were in each house. So let's have a look at our data. Here it is. So when you're drawing your bars, it's often quite good to use different colours to distinguish between the different categories. And you need to clearly indicate the number in each. So you can see here, 7 is the yellow bar, and you can see that 7 people were in Severn because it stops here where the 7 would be. Trim also had 7 people, Avon had 6, and Frome had 9. So here is what our completed chart would look like, and it's quite easy to read the data. Okay, but you need to choose an appropriate scale depending on where your data goes up to. If it was a bigger number, you'd have to choose a bigger scale. Okay, and when drawing a pictogram, make sure you use an appropriate picture that can clearly show your scale. So this is using the same data as the previous chart, so the school houses, but we've got a key here this time. So a circle represents 2 children, and half a circle or a semicircle represents 1 child. So here you can see 2, 4, 6, 7 people in Severn, 2, 4, 6, and 1 more, 7 people in Trim, 2, 4, 6 in Avon, 2, 4, 6, 8, 9 in Frome. Okay, so if you're doing a pictogram, you might want to use a key. You can choose a picture where you can do half a picture, which represents half of what the full picture would be. Okay, so moving on to our worksheets. So you'll do it today. You're going to be using this data to create a table, a pictogram, and a bar chart. And the data is made up, it's 20 different children and what type of pet they'd prefer. Okay, and you've got the options of fish, dog, cat, lizard, and rabbit. So it's 5 different choices, 5 different categories. And you need to use this data to fill in the table, how many children wanted each pet. And then you also need to do a pictogram and a bar chart. Once you've done that, moving on to your Solve It, you're going to be making up questions which we could ask about the data. So here is some useful vocabulary that might be that you might want to use for this task. For example, how many more children liked one pet than another pet? Or how many less liked it? Or how many children liked one certain type of pet? Maybe which was the most popular animal and which was the least popular animal. Okay, lots of different questions that you could ask about the data. Okay, well that's it from me for today. If you are finding the sheets a little bit tricky, feel free to watch the video again, and good luck.